Hi, welcome to Final Pi Videos. This is DC here. In this and next few videos, I'll be showing you how to use the NXP ICODE SLIX2 tag using P15180 board. Now, this is what I intend to cover in this videos. So this tag, it's very difficult to cover in one single video. So I would not like to have a video which is a couple of hours in length. So instead I'm going to do this in 2 or 3 videos. So first of all, at the end of this video series, I'm 100% sure you will have understood everything about SLIX2. You can call yourself as a master of SLIX2. So as usual, the first thing we do is understand how the memory is organized in this tag. We're going to go through all the commands of SLIX2 and you're going to learn how to program these tags, how to send various bits and bytes of these commands. I'm going to show you now using my learning software and about showing you how all these commands work, and this demonstration probably will be in my next video. You're going to know the differences between the ICODE SLI, SLIX and SLIX2. And with this you're going to appreciate how the tags have evolved. So we already seen the video on SLIX, SLIX and SLIX2. If you follow these 3 videos, you will gradually know the evolution of this tag series. And I'm going to do in this video, I'm going to do the datasheet walkthrough. This is very important for you to understand before you start coding. And again, the more tags, obviously the more videos are going to come. So like there are tags called SLIX, you got ICODE DNA, and you got ICODE ILT tags, and there could be more tags coming in the near future. So these are some of the important features of SLIX2 tag. So first of all, this is backward compatible with the SLI and SLIX. So you can use this tag as either SLI or SLIX. It will work. This has got more memory. This has got nearly 2 kilobits of memory, which is organized as 80 blocks and 4 bytes in a block. And you can split the memory into 2 pages. One is the lower page and the higher page. Now this is a very interesting feature where you can divide an application into 2 parts. Like you can have a read-only section and a read-write section, or you can have 2 applications in the same tag. Now if this is the main memory, it's divided into upper half and lower half. And for each of these pages, you can also designate the read and write password. So before that, now this tag supports the read and write password for the user memory. We have seen the user memory in SLI and SLIX, and none of these 2 tags have got a password protection for user memory. Now this tag does have passwords. You can have a separate read password and a write password. It has got a feature called the privacy mode. Now this is a very interesting thing you'll appreciate when I give a demonstration of this command. So in the privacy mode, the tag literally does not respond except for a very specialized or designated commands. So you can think this as the entire tag that is protected. So you can only see the tag content after you submit the privacy password. This is a very interesting feature to have. It has a command to destroy the tag, and once the tag is destroyed, you cannot store any data. The tag does not respond to any commands. Now this is something interesting as well. You can get the information about various locks and the feature. If you remember in SLI and SLIX, it's very difficult, or you just cannot know whether the AFI is locked or whether whether any feature is locked. And here also it's very difficult to find out whether the EAS is password protected or whether EAS locked. There's no way to know that information with SLI and SLIX tags. Whereas in this SLIX2 it's possible. It gives a list of all the locks and various capabilities of the tag. It has got a counter. If you have worked with any other NXP tags like NTAG 213 or kind of ultralight C, there is a counter functionality there. Even this tag also has a counter functionality. So I'm also going to show you then, probably you can see in the comment section of this video, where to buy these tags. It's not easily available for you to buy in say 10 or 20s. Now you have to either buy hundreds, or so I found out one website where you can buy this in tens. Next, you have to get the datasheet of SLIX2. If you Google ICODE SLIX2, you'll end up getting this document. Now this is a easy to understand document if you have gone through my earlier videos on SLI and SLIX. However, if you are coming to this tag for the first time, you will find this tag is very complex. So what I would advise is, if you follow the way I demonstrate this tag, you will understand every aspect of this tag. Then once you master this basic concept, once you know all the features and how it works, then you can put your knowledge to create whatever you want. So as you can see here, this document is not very old. Looks like it's the latest one. One thing I forgot to mention in my earlier part of the video is, so this tag supports what is called as the NXP originality signature check. Now this feature is also available in tags like NTAG 213 or MeFair Ultralight EV1 and the DeskFire. So in all these type of tags, it is possible to check whether the tag is indeed manufactured by NXP. So there is a signature which is stored inside the chip, which you can read out the signature, and you can also verify whether the signature is valid or not. So that's one of the I think this is the first tag to introduce in the ICODE series, to introduce the NXP signature. And there are so many things, all the features, robustness and speed, I'll leave that to you. But to summarize, okay, this is a very interesting document to read. So read couple of times, so then you'll master this concept. Now what I'm going to go to later part of the video is just quickly go through various instructions, and the first thing you have to do is go through this type of feature document here. Say some of the things which I would like to point out here is, so it has got the privacy mode. So if you enable the privacy mode, then the tag it's not readable until unless the privacy password is set. And it also has got a destroy command. You can destroy the tag, and this tag will never respond for any read and write operation. There's an interesting feature which is in this tag. It's called persistent quiet mode. Now this is also interesting. I'm going to cover this in my future videos. Regarding the memories, you can see it says it has got 80 blocks of 4 bytes each. Look at these features here, they're very interesting. Now some of the things we already seen in SLIX tag, say for example, you already seen how to lock DFID. You have seen how to lock AFI and ES. This feature is already available in SLIX. Look at these ones. It has got a separate read access password, a write access password. it has got a destroy password, a privacy password, and the ESAFI function password. The way the password works, like if you remember from my SLIX video, the way you send the password to this tag is first you start with a get random number. Okay, you get a random number which is a 16-bit, then assume that the password is a 32-bit. It has got 4 bytes of password. Then we have seen this concept. Okay, now this is the 4 bytes of password. What you do is you XOR the 16-bit random number twice. So you XOR with the first 16 bits of the password, the highest 16 bits of the password. The XORed output is what you send to the tag. Now it's a very similar way here as well. So almost 50% of the password functionality you're already aware of if you have seen my previous video. And something I noticed about this this particular tag is, so I've seen a couple of articles on this tag, and most people mentions this is used in the libraries along with the book. So not sure, maybe this is popular in the books because of the cost. So this is the memory structure. So we have got 80 blocks to play with. However, the last block is used for the counter, and also this, it is a 16-bit counter. So the first 2 bytes are used a counter, and the last byte is used to set the read and the write password for the counter itself. So the block number 79 cannot be used as user data. Everything from the first 79 blocks can be used as a user data, and you can split this into 2 pages, and you can have a read and write password. And keep in mind, the password is the same for both the pages. So next, there's information about how to identify this tag is SLIX2. So here it says the tag type is set to 1, and you have to check the bit number 36 and 37, and you can find out whether, based on the values of these 2 bits, you can find out whether it's SLI, SLIX or SLIX2. And this originality signature. Now this section is more or less the same you've seen elsewhere in NTAG 213 and so on. Now also, as I mentioned about what is the default value of these tags and the default value of this locks, when you buy a new tag, the most interesting thing here is all this password, the read password, write password, and the password for EAS and AFI lock, the default value is all zeros, whereas the password for the privacy and the destroy, the default value is all 0f. So the password here is 0f, 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 4 times of 0f. So my computer is slow here, it's not writing. So if you look at this state diagram, if you compare this with the SLI and SLIX, so you have seen this, we have seen that, and you have seen this and that. There is a new state diagram called a persistent quit, which I'm going to cover in my future videos. In fact, so if I'm not wrong, I've still not covered the working of these state diagrams. Probably I'll try to do in my next videos. Next is about all the various commands supported by this tag. Now you have seen the inventory command. This is the mandatory command. Inventory, we know. Stay quiet, we have seen. You've got to read single block. Then after that, you got write single block. You have seen this a couple of times. Now also keep in mind, in the write single block, it supports with option flag is equal to 1. And just to recap what it is, when you write with the option flag set to 1, we have to send, or the reader has to send, a end of frame signal in order to receive the response from the tag. So that is also supported here. And you got a log block, which you have seen. This command used to log the block. and you can read the multiple blocks. I've seen that. And this is some of the ISO standard command, like a select, reset to ready, write AFI. Again, because the AFI can have a password protection, so sometimes the write is possible only after the password verification. And similarly, lock AFI also, if it is already locked, if the AFI is password protected, you need to first submit the password before you lock. And you got to write DSF ID, log DSF ID, and get system information. And all these commands are very similar to what you have seen in SLI and SLIX. And the custom commands are very interesting here. I think this is because of the custom commands, you find this tag very powerful. We have seen how the get random number works. It's the same structure, same command code, and the response is the same. This, before you submit the password, you have to get the random number and you have to XOR it. That's what I mentioned a few minutes ago. And that's what the command is, get random number. After that, set password is the same. However, remember, we have got more password in this SLX2. Now, we have seen this structure in my earlier videos. Look at that. In the earlier videos, the set password was only for the EAS and AFI. Whereas here you got 4 more password, additional password for read password, write password, privacy password, destroy password. Now that's what the password is. Write password is same as to change the password. And again, we have seen this in my SLIX video. The structure is the same. Because there are more passwords, you'll have more value for this password identifier. Lock password, we have seen this. Once you have set the password, you can lock it. Again, you can lock any password at a time. Now, there's something called 64-bit password protection. Now here, what it means here is, okay, now we are going to see a working of this. If you read the description here, what its final says is, so if it's a read password, if it's an ordinary 32-bit read password, the reader sends a 32-bit number, which is the read password. Whereas and also if you want to write it, you have to send the 32-bit the write password. Okay. But if I enable this 64-bit password protection, you have to set both read and write password. So read is 32-bit, write is 32-bit, both put together 64 bits. So only then you are able to read and write. Now this is a like additional protection. It also means the reader or the user have to know both the read and the write password in order to do either read or write operation. That's what it's all about. Protect page. Okay, now this is the command used to split the entire user memory into 2 pages. The upper page is called, if you see this structure of this is a very nice table here. Now here the first 80 blocks, or the 80 blocks can be divided into 2, the top section, bottom section. And remember this, the counter, this is not part of any pages, so that's why the table, there are, looks like the 3 tables here. Okay, now this is the upper part called page L, the lower part called page H. Now both the parts can be set whether they need a password or they're not. So that's what you do with this protect page command. There's information here, and once you get used to this sending the bytes and bits, okay, all these things are secondary. They are very easy. So here you can set whether the lower page L is read protected or write protected, or page H is read or write protected. All those things can be set here. Now that's what I mentioned this before. If the 64-bit password protection enabled, you have to send both read and the write password in order to do the read and write. Lock page protection. The page protect command is used to divide the user memory and also to set the various access rights of the individual pages. Once you have done that, you can lock the protection by using this lock page protection command. Destroy, what it says here is, destroy is password protected. You can't just destroy a tag. You can destroy only when you know the destroy password. Now once the tag is destroyed, after you send the destroy command, the tag becomes unusable. I think I've seen the working of destroy. The only thing that works after the destroy command is to get the random number. So even the destroy tags are, no, you don't have to pin them. It works as a random number generator. That's an interesting thing. Now enable privacy, again I mentioned before, there's no description here. Probably you'll understand the description once I show you how the enable privacy works. So enable privacy is a way of protecting your entire tag, where the user can the tag will start responding to the commands only after after the user or the tag or the reader sends the privacy password. So that's what it's all about. Inventory read, we have seen this a couple of times, and this inventory read has got fast inventory read. That's pretty complex. I'm going to explain that in my video. In fact, 3 or 4 pages are used to explain inventory command. Now we have seen this set EAS. We have seen this right from SLI. There's literally no difference here. It works without any change. You can set the EAS, or you can reset the EAS, or you can lock the EAS. The only thing probably here is the lock EAS could be password protected. In that case, you have to send the password. EAS alarm is also the same thing. Okay. Now, the interesting thing here is there's a feature called EAS ID, so which is not there in the earlier cards. So password protect EAS and AFI, we have seen this in SLIX. So if you want to make any changes to reset or AFI change, you must submit the password first. EAS ID is a new feature here. So there is some, just like ASF ID and DSF ID, also got EAS ID. I'm 100% not sure when this is used. So if you think from the developer's point of view, now you can set the value of EAS ID. So just a simple a write operation. Now this is the interesting thing I mentioned before. This tag can tell you the various locks bits and the password bits, and also the various features that are available in the tag. This is called get NX system information. So this returns you so much of details. If, for example, this tells you whether there is a paging, in a sense, if there is any page L and page H, and if it is, it also tells you whether it's read protected, write protected, and so on. And also tells you whether if AFI lock is done, if it's locked or not locked. And also look at the feature set here. It tells you whether account is available, whether the username protection is supported, okay, whether inventory, something, there's so many things, whether original signature is supported, whether the original signature is there. And it can also have the password for original signature, which is not available in this tag. Probably the future version of the tag might implement this password for the original signature as well. So you got the stay quiet persistent. This is the additional some similar to say stay quiet command, which you're going to see. Read signature. So this is the command you can use to read the 32 bytes of signature, and this is very similar to what you have done in NTAG 213. You got a counter here, and you can increment the counter. You can set the counter initial value. All those things can be done. And I think more or less that's all we have covered the entire data sheet. And in the next video I'm going to show you, I'm going to play with the SLX tag. Okay, thanks for watching.